everybody, I hope you're doing well and welcome to the channel of CodeChef. So today we'll be solving the problem Unit GCD whose difficulty level is simple and the prerequisites required for this problem are the simple mathematics. And this is your educator Ansh and I hope that you would like my video. So let's just move on to the problem statement. Okay, so first of all, it is my humble request for all of you to kindly go to the problem statement once carefully before moving on to the solution. Okay, so now let me just summarize the entire problem statement. So basically, Chef is reading a book which is of n pages. Now, what is the speciality of Chef is, Chef cannot read any pages which are co-prime with each other. So what do you mean by co-prime? So any two numbers A and B are said to be co-prime if their GCD, like my GCD of A comma B is equal to 1, or the greatest common divisor of my A comma B is equals to 1. Example, as you can see, my numbers 1, 3 and 10. So like my greatest common divisor of 1 comma 3 is 1. My greatest common divisor of my 3 comma 10 is also 1. And also my greatest common divisor of 1 comma 10 is 1. So all these three numbers are mutually co-prime. So consider the book having pages from 1 till n. So 1, 2, 3 and so on till n. And Chef is saying that he can only read pages which are co-prime with each other. So now Chef wants to determine, like at any particular day, say on a ith day, Chef can read any mutually co-prime numbers. The pages which have mutually co-prime numbers. And then Chef is asking what is the minimum number of days Chef will require to finish this particular book, and also you have to print on which particular day Chef reads what amount of pages, right? So let me just show you the sample test case so you will get a clear understanding. So we have 5. So initially, so let me just clear this particular screen. Yeah, so initially we have 5. So I have my 5 pages. I have my book number 1, 2, 3, 4, 5. 5 pages in my book. So what does Chef do here is, my Chef reads 1, then Chef reads 2 and 5 on the first day. And as you can see, all of these numbers are mutually co-prime. So the GCD of 1 with anything will obviously be 1, but GCD of my 2 comma 5 is also 1, so it is also co-prime. So Chef will complete these pages on the first day. So first we output 3 as my number of pages, like that the Chef will exhaust on that particular day, and then we print 3 integers, like we print 1, 2, 5, denoting that we complete this page on this particular day. And similarly, on the second day, since my 3 and 4 are co-prime, Chef will read them on the second day, and then he will exhaust those particular pages also. So it takes 2 days, and on the first day Chef reads 3 pages, 1, 2 and 5. On the second day Chef reads 3 and 4. So this is how my output is generated for this particular question. Now let's move on to the approach how to solve such kind of problems. Okay, now let's try to form the approach for this particular question. So now for n equals to 1, it is fairly obvious that it will take Chef one particular day, and that too he'll read 1 and 1, like for one instance, and that too page number 1, and he'll complete the entire book. So let me handle this as my edge case and keep it outside. Now for any generalized n, let us observe what we can do. So I am taking here my n is equals to 10, and let me take my n equals to 11. So now here I am generating my 10 pages, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I want you to have one crucial observation, that first of all, instead of looking at the pages which can go together, let's look at the pages which cannot go together. So for that, my condition was any co-prime numbers like can go together on same day. So for the numbers who cannot go together, they do not have to be co-prime, they strictly don't have to be co-prime. So the GCD of A comma B has not to be equal to 1 for them to go together on one day. So as you can see, what are the numbers that dominate the entire meta? That's right, the multiples of 2. So as you can see, 2, 4, 6, 8 and 10. each of this particular number is not co-prime with each other because GCD of 2 and any multiple of 2 will obviously be equal to 2, which is not equal to 1, and hence these numbers are not co-prime. Now, so I'm sure that my multiples of 2 cannot go on together on a single day. So let me just put my each multiple of 2 on a different day. So I put my 2, I put my 4, I put my 6, I put my 8, and I put my 10, each on a different day. So total now I have 5 days currently. Now so I have only odd number remaining here. So I have 1, 3, 5, 7 and 9 remaining. So can we accommodate this number somewhere in this particular numbers such that our condition still remains satisfied? So I want you all to have a crucial observation. So here if I put my 1 and 2 are still co-prime, so they can go on the same day. Similarly, if I put 3 and 4, they are still co-prime, so even they can go on the same day. Similarly, my 5 and 6, they are also co-prime, hence they can go on the same day. 7, 8, 9, 10, and similarly we can keep on filling and exhaust all the numbers. So we can fill in this particular pattern for any even number where n mod 2 is 0. And let's take for odd number also. So in odd number, what will be the only difference? So here we'll have 11 numbers. So we'll have 2, 4, 6, 8, 10. Let us reassign the following numbers, which is 1, 2, then 3, 4, then 5, 6, then 7, 8, then 9, 10. The only thing remaining is my number 11. So is there any place where I could accommodate 11 or I have to create a new entry? So I want you to observe one thing very carefully. Consider any particular consider my first thing where I am using 1 and 2 together. Here if I put my n, I know that my n is not equal to 1 because I have already handled that case here. I know that my n is not even because all my even numbers are included here. So that means that n is an odd number which is lying in 3, 5, 7 and that all. And any of this particular number is always co-prime with 2. So we can always put n in this particular domain in the first day. So on the first day I can simply read 1. 1 is co-prime with any particular number. My 2 is co-prime with all the numbers which are in the set 3, 5, 7, 9 and so on. And since my n is co-prime with 2, I can include it in the first day. And then so forth I can keep on reading I minus 1, I minus 1. So 3, 4, 5, 6, 7, 8, 9, 10 in this particular day. So every time, as you can see, my number of days will be nothing but floor value of n divided by 2. So for n equals to 10, my 10 by 2 is 5. So it takes me 5 days to read the entire book and we can print our days in this particular fashion. Similarly for my n, which is, so for n equals to even, so for n equals to odd, we can do the same thing. Like we can do the n by 2, which is 11 by 2, which is again 5 because we are taking the floor value, and the 5 for 5 days we can arrange them in this particular format in order to get a required answer. So yes, this is the approach for this particular question. Now let's go on to the coding part. Okay, so now let's discuss the code for this particular problem. So as you can see, first we included all our fast IO templates, then we included my t as my number of test cases. For each t I inputted n, right? And then if my value of n equal to 1, then I handle it separately as I discussed in the approach. Otherwise, as you can see, our total number of days were n by 2 as we discussed, and that too floor of n by 2. So now if my n mod 2 is equals to 1 or it is the odd number, then as you know, we accommodate 1, 2 and we also accommodate n because this n always lie in the range of 3, 5, 7, 9 and so on, and that is always co-prime with 1 and 2, so it never violates the condition. So the extra odd number can be accommodated here, and then after so on, and also in the case of my even, so in the even we can just use 1, 2 and there's no need of this extra number to be accommodated because there's no number, right? And then on so forth we can apply a particular logic that we print I and I minus 1. So with 3, 4, then we print 5, 6, we print 7, 8 and so on till all the n get exhausted. So yeah, this was the approach for this particular code. Now let's just see the test cases running on this code and see everything is working correctly or not. So as you can see, we got a required answer given in the question. Now let's submit our particular code and see everything is working or not. So let's just check. And the code is submitting. And as you can see, we got the correct answer for this particular problem. So this is the way how we could solve that. Now, I would like to tell you why people could go wrong in this particular problem. So the main observation here was that 2's multiples are dominating the meta, and finally, the last nth number can be accommodated on the first day directly. So yeah, that are two crucial observations, and sometimes people might miss that, and due to that they might get some wrong answers. So yeah, if people were able to figure that out, I don't think there's any syntactical or any problem in this particular question where people could go wrong. Also, the time complexity of this problem is big O of n, since we are just traversing n and printing as per our required format. So yeah, I hope you like this particular video. Please like, share and subscribe to our channel. Thank you.